Yeah. Okay. So hi everyone, welcome to our talk. So today we'll be discussing SSO and SAML Pentesting. So a lot of times we come across like SAML as authentication mechanism, and usually in enterprise applications, SAML is something that you see very commonly. So it's usually used for the websites or entire infrastructures. So if I talk about like the in terms of like what you might have seen, so when we talk about say Uber or say Yahoo, who have like millions of subdomains and different internal portals as well, and a lot of things such as Jira dashboards or maybe any other kind of service that they're running. So in those like places, a lot of what happens is that, for example, a website is having say 50 to 100 subdomains, and if you as a user want to access maybe say 10 or 15 subdomains, so definitely you're not actually going to like log in again and again in each of them. So there comes a concept which is known as single sign-on, and we have implementation of SSL, SSAML. So we'll just discuss. Uh, so, uh, so in the beginning, just a brief introduction about us. So I'm Abhinav, and you can find me on Twitter at OXentry. So I'm a bug hunter on Bugcrowd, as well as I'm into web pen testing and API. So I've spent most of my time over there. And apart from that, I'm also having experience in Docker and cloud and all the virtualization technologies. So
Yeah.
with me, we have.
Yeah, and I'm Naveen. I go on like all the social media handles as iPanda915. I'm a bug hunter on Bugcrowd. I do web pen testing as well. And like apart from security, I also have my experience in machine learning and cloud technologies.
Yeah. Okay. So let's get started by first understanding what SSO is, what it expands to, and what is SAML, and what are different kind of implementations. Then we'll move on to what are the different type of attack scenarios that you can try to overtake maybe accounts, log in as admin users by identifying the weaknesses that are there, and then we'll move on to preventions accordingly. So the first that we have is what is SSO. So a lot of times, like I'm pretty sure that most of us must have come across, what like SSO looks like, but sometimes you're not aware about what kind of technology that they're using. So a lot of times what happens is that whenever you go on a particular website, what happens is there's an option for sign in with Facebook or sign in with maybe say Google or any other maybe say Twitter or any kind of website. So that is actually known as single sign on. So what happens is that once you do it on maybe say Google's website, so if you log in on google.com, so you don't have to actually just log in on other like different types of domains that are hosted. So as it has been mentioned over here as well, that if you like log into just google.com, so you will definitely be able to access all the other services that are provided by Google, such as Gmail, or it could be YouTube, or either if you just look at Play Store as well, so you are automatically signed in that particular thing. So as the name itself suggests, single sign on, so you just have to sign in once to a particular application, and all the other applications that are linked to that particular service, so you get simply logged in into it.
So now let us see what is SAML, the topic of today. So it is security assertion and markup language. So what do we mean by security assertion markup language? It is one of the ways in which SSO can be implemented. And how this works is we do have someone called an identity provider. Let us say someone like Google or Gmail who provides us with an identity using which we can log in with various other service providers. Service providers can be ranging from the Google Drive, which is provided by Google domain itself. And we also have the login with Google options on various other platforms like TripAdvisor maybe. And we do even have them for like wherever, like in Medium, or we do even have them on various other bug hunting platforms as well, where we can just use this particular thing of login with Facebook, login with Gmail, or login with Microsoft accounts, so that you do not have to carry a separate set of credentials for all the separate services provided. So SAML makes it easy for us to handle, uh, have the credentials in one place so that we can use one set of credentials for many different websites.
Yeah. So as he said, that SAML is one of the ways to implement SSO. So broadly speaking, we have three ways to implement it. So first one, if we just quickly discuss what all are them. So one of them is cookie sharing. That simply means that if say for example you are on a particular website, for example uh, Facebook.com. So once you log in into Facebook, you will be just assigned a set of cookies, and what the application does is whenever you want to just access any service that is associated to Facebook, so they'll be picking up your cookies in order to see that okay, you are authenticated as a particular user, and then they'll just simply try to re-login you again in all other services as well. But this does not work in much cases, because for example you are logged in on facebook.com and you want to access messenger.com. Now because both of the domains are different, so cookie sharing might not be possible based on what flags are being used by the application. So the other possibility that we have for today, and we're going to discuss it in like depth, is SAML. So we're going to see what SAML is, like in how the workflow of SAML is when it comes to authentication. And the third one is OAuth, that we just is also a token based system that we have, which can be used. So in OAuth, what we do is we simply don't provide any sort of credentials to anyone. The application just simply works on the basis of token that is generated by a particular application. So there are different types of ways of implementing SSO. All of them have their drawbacks as well. Some have advantages over others. But SAML, you will come across like the sample implementation in large infrastructure networks, where they have a lot of domains, and again and again, if you keep on using different domains, so it becomes impossible to like log in each and every time. So if we just look at SAML, so these are some of the very common ways or very common areas where you'll actually look at or how SAML looks like. So Okta is one of them, which is very widely used in a lot of applications. We'll be discussing examples where you'll see how, like for example, if you want to hit an internal domain for say website, so it simply redirects you to Okta, and over there you have to first log in into Okta, and then it just authenticates automatically with all the domains that are there. So one login is one of them, New Relic is one of them, and even Google has its own like SAML implementation as well. So there are a lot of services that like can be used in order to authenticate a particular system, or in order to just set up authentication mechanism. So we'll discuss like how it actually works.
So now let us see like how SAML authentication actually works. So here at the top, we can see that there are three major components. That is the user agent, that is basically the user himself, the service provider, that particular company or person who is providing us with service. For let us say, let it be some kind of photo sharing service where we are going to access some photos. And identity provider is the one who is going to authenticate and provide the authorization. Let us say in this particular case, Gmail. So what happens first is like when we are going to have some kind of or fetch some kind of photo from some kind of service provider, what we do first is we go to a user agent, that is usually a browser, and request for that resource from our service provider. Now the service provider does not know if we have the particular authorization or if you are authenticated to access that particular photo. So what it does is it sends and redirect to the IDP with the SAML request. So what to our user agent, so that is the browser. So now what it does is the user agent follows the redirect and access to the IDP. So what it does is this particular user agent takes this particular redirect and goes to the identity provider with the SAML request. And the identity provider evaluates the SAML request and sends back the SAML response. If we are a valid user and if we have like a particular authorization to access that particular thing, in the step 5, we have a valid SAML response, which allows us to be able to like log in into that particular service so that we can fetch the resource. And in the 6th step, what the service does is it like we are logged into that particular thing and the user is logged in, and hence he can access all the particular resources provided by the service provider. So this is an overlay of how SAML authentication works.
Yeah, so like it can be complicated at times to like understand what this thing is exactly. But while pen testing, the main focus that we have is on step number 5. That is when the like the SAML response is sent from our browser to the service provider. So here we have a lot of things that we have to look for, while we are pen testing, and we'll be discussing those. So if it's kind of confusing to understand initially, what all these terminologies are. So just to break down with an example, if you consider the user agent, it's simply our browser. So we as a user are using our browser. Maybe it can be Chrome, or it could be even Firefox, for just simply browsing the internet and accessing a particular service. The service provider that we have could simply be your say something like Dell. So for example, Dell also has a lot of services. I mean, they have like thousands of services if you just properly map out what all comes under Dell's infrastructure. So the service provider is Dell, because any sort of service that you are using is being provided by Dell, so it is assigned as a name of service provider. Now, obviously, if Dell has thousands of services, they cannot keep track of each and every user, their authentication mechanisms, what credentials that they are using, because it will be a lot of overhead for the company itself. So in this case, what they do is they just map out each and every service that they have with a common platform where it can simply authenticate us once, and all the services will take privilege of that thing, and it can be just tallied or verified from the identity provider that okay, the person has logged in on one end, and now they are able to access all other services as well. So Okta is one of them, which acts as an identity provider over here. So basically, once you create an account, the identity provider is the one that is going to validate your identity, and it's simply Okta is going to tell Dell that yes, this person is valid, and you can just give access to all the thousand services, whatever are coming under the privileges of that particular user. So as I discussed, that we have to just focus on this SAML response that we have, which is sent back from the entity provider to the browser, because this is a response we can't do much. But in the fifth step, we can actually just do some manipulations, because we can just simply capture that particular response and look at how things are working over there. So this is what a SAML response looks like. So because this is a very large document, it is an XML based document, so there are a lot of things to look into, but majorly the vulnerability that exists in this particular response are somewhat related to, we have a signature value which simply verifies if a particular request that is coming or response that is coming is not being tampered in the middle. And then at the bottom, if you could see the ones that are put in the rectangle, so these are where the usernames and privileges, as well as your email addresses are there. So we'll be discussing the prime focus over here as well, because what we want to do is we want to switch users from low privilege user and try to become admins. So we'll have to look out for parameters or places where we can actually replace the admin email addresses or admin privileges or maybe admin usernames.
So, if we visit some kind of an SAML page, so here you can see that it is for Dell.com, and we have something known as SSO.SAML2. So here we can see that here we do not have something like, if you're a Dell user, and as we have already discussed, Dell has multiple services. So there we cannot have separate set of credentials for all the services. So what Dell has provided is they have provided with two of the SAML services, that is Dell user and as a non-Dell user. So as we have already previously discussed, we have this thing called Saml Response. So what we'll be focusing mainly in the Saml Response is the part known as Saml Assertion. What is Saml Assertion? Saml Assertion is the part where the signature and the other attributes of user are contained. The other attributes of user can be like the user name ID, or basically the particular unique ID which identifies the user. And if there are multiple levels in that particular system, like there can be someone who is a manager, someone who is not a manager, and someone who is an outsider of the company, such permissions are also handled in that particular assertion. So this is what a typical SAML authentication page looks like.
Yeah.
So
in a nutshell, when you want to log into Jira service on Dell, so they won't ask you for credentials again and again. For example, if you want to switch from Jira to something else, So they'll just redirect you to this authentication page that they have of SAML implementation, and over there they just simply ask for credential once based on if you're a Dell or a non-Dell user, and then not only Jira, but you'll be able to access all other services that are attached to this particular authentication. So now we're going to talk about the different types of scenarios that we have, what all we can test for in this. So first we have a scenario one. So Naveen, if you could
Yeah.
explain.
Yeah. So in scenario one, this is like a simple account takeover by manipulating the SAML response. So since we've already seen that SAML response is sent by the IDP to the user agent, or the browser is sent to the browser to service provider. So what we can do is we can use like a proxying service like Burp Suite and capture that particular request. So this is how a typical request looks like. So here we do see the authenticity token, which is like just to verify the authenticity. And here we can see a large text that is the SAML response. So basically this particular thing is an base 64 encoded thing. So when we decode this base 64 thing, like there are multiple tools over the internet to decode base 64 if you have any doubts regarding that. And we also have this particular thing of base 64 already installed. We can just simply use base 64 minus D command on if you are using some kind of Linux operating system to decode this particular thing. There, what we do have is the assertion part. And the assertion part sometimes contains this particular thing called as a name ID, which is used to verify who the user is. So for suppose, what we can do is we can intercept that particular request and decode the SAML response and see like that the user here is testuser@gmail.com. What can be done is it can be changed to admin at the website.com. For suppose if you are using some, let us take for some kind of ABC company in as an example, what we can do is we can change the email address to be or name identity to be administrator@abc.com, or maybe some kind of administrator with change capitalizations and everything, and forward that particular thing. And why does this particular attack work? Sometimes what happens is even though there's a signature present to verify if that particular thing is tampered or not, but most of the times what the developers forget to do is they do not verify that particular signature. They only see if a signature is present and that is it. So sometimes changing that particular name ID from test@user.com to admin@website.com can lead us to taking over the admin account. And these kind of vulnerabilities are pretty much common in like web application pen testing if you're working for some kind of consultancies or even bug hunting. So this particular thing is an extension called SAML Rider. What this allows us to do is like this particular extension, the particular thing that I've already told you that the SAML response is usually base 64 encoded. What it does is it provides us with an platform or says a separate tab in Burp Suite when installed where we can tamper or like basically change the parameters and re-encode that to the base 64. And like it makes the whole process easy. That is taking over that particular SAML response, base 64 decoding it and changing the parameter that we want to change. Again, like re-encoding that particular SAML response to base 64 and then forwarding the request.
Yes. So like with the help of SAML Reader, you won't be like, you won't have to just decode the base64 SAML response, change the values and encode it again. It will just simply show you in the simplified format. And as you can see in this screenshot that we have, we just simply changed it to admin@website.com. And when you forward this, so the like service provider or Dell thinks that the request has been made to, log in as an admin, and it might actually give you the admin like rights for the website that you are trying to access or the service that you are trying to access. So here in this scenario, in a nutshell, what we do is just simply decode the SAML response, swap the user to the admin, and sometimes it might actually lead to the admin, takeover. And this has been like a very common scenario because it's only due to the implementation failures that are there in the SAML responses. So the second scenario that we have is account takeover by SAML signature stripping. So in the last slide, as Naveen discussed, that the websites, what they usually do is they do attach a signature value, that is there to check the integrity of the response that is coming. But a lot of times they don't validate that signature value, and even if they do validate the signature value, there lies a vulnerability that if you remove the contents of the signature value parameter that we have, so it thinks that okay, it is like a null signature value and it does not verify that particular thing. So in the above screenshot, if you see, there's a signature value that can be seen in the decoded like base64 decoded SAML response. So if we just see this particular thing, and if I forward by this request by tampering any sort of data, so the data that is received by maybe say Dell won't actually match the signature value that is attached in the like response over here. So SAML response. So this will be a contradiction. So to overcome that, what we do is if we just simply remove the signature value itself, and we don't like have anything in that particular value, keeping it as null, and then we try to modify. So the Dell's website will not have anything to compare that signature to. So in that particular case, what happens is, your particular like thing could be very very easily bypassed, because if you don't have a signature value to tally to your particular content that you are receiving, so you can like change any kind of thing. So like in the last scenario, what we did is we just simply changed the admin at website.com, but once it is received by the service provider and it generates a signature, and if the value does not match this signature value that you have over here, so this could cause a problem. But in the next scenario that we're discussing, signature stripping, you simply remove this value so that it does not have anything to compare the like response with, and that could actually lead to another account takeover. Because if you don't have any signature value, so there won't be any objection that will be created by the particular like application. And this was something that I like we found out on a live pen testing environment. So there was a website for a Jira of a domain. So if you want to access the Jira of the target.com, the subdomain of Jira, so what happens is because it figures out that you are not logged in into that Jira instance, so it will simply redirect you to Okta. And once you get redirected to Okta, what happens is you get this kind of infrastructure. Like it asks for your email address and network password. So basically, what it means, if you just look at the URL, this is SSO/SAML. So by this, what we mean is that it redirects you to Okta, which is your identity provider, and this is like a common ground that they have for logging in. So it will just ask you for logging in over here, and all the other subdomains apart from Jira will also be granted access to those as well, and you won't have to like log in again and again. We simply just put in the email and password that we had been given while pen testing. So once you put in those, you capture the request, and you can simply just remove the signature value that is generated by Okta. And once you forward it to the website, so it thinks that Okta has given the permission to log in as a particular admin, and that could actually lead to this thing. So again and again, what we are like focusing on is the SAML response itself. So that is generated by the particular identity provider, and it's given to your browser. So SAML Radar makes it very easy to like capture that thing, and either you can strip off the signature value so that anything you tamper does not get validated. It does not have something to validate it to. Or secondly, you can just simply like change the email addresses and try to see if you can get the admin access to these kind of things. So like this is how the normal SAML request that we're talking about having the SAML response is going to look like. So usually the endpoints confirm that okay, as you can see, it is using SAML 2.0. So we come to know that okay, if there's a SAML implementation, so now we are interested in this SAML response value that you can see over here. So this SAML response, the PH and all the values that you see, all of it is base64 encoded, and this can easily be decoded, by using extensions such as SAML Radar, which can be installed in Burp Suite very easily. So once you decode it, you will get something like this. So it will be a plain XML data. So based on what kind of attack you want to perform, maybe you want to change or switch it to admin. And secondly, what you want to do is you want to just remove the signature from here in order to see if it allows you to do such kind of thing. So we are always looking for this SAML response token that we have. And this text that we have over here is simply base64 encoded. So we have other attack scenarios as well.
So yeah, like since we have discussed the like those two attack scenarios, 1 and 2 were some of the common vulnerabilities that other people have been finding and we ourselves have been finding in like internal pen tests and as well as bug bounties. So there are also other attacks that can be performed on SAML. So one of the attacks being XXE via SAML. So XXE is basically external XML entities. Since we have already discussed, SAML is nothing but a large script which is documented in XML. So what can happen is sometimes we can also include the external XML entities payload in that particular SAML response and append it. And if we encode that whole content and if we send it, there are large like it is. We do not say it is a large probability, but in some cases, our XXE payload might trigger, and we might be able to extract or like exploit the XXE in that particular system. And so an extension of XXE via SAML can be like we already know XXE. When we have an XXE, we can also try for SSRF. There have been many scenarios where some of the hosts are not like we cannot directly access few domains or hosts or IP addresses of a target. So what can be done is once if we like successfully exploit some kind of XXE, then we can also try to hit that particular internal host via XSR like SSRF using XXE. So here we have one of the famous bug hunters, Brett, who like successfully did this.
Yeah, so we've also attached a link to this where there was an internal domain on Yahoo which was not accessible directly. So there could be multiple reasons. Either it is behind the SAML authentication, it could be behind a VPN, or it could be placed inside any restricted internal network. So it was not directly accessible. But once you figure out a way that through SAML response you're able to interact with the internal system, so obviously you can try to hit those internal domains. And for those kind of payloads, such as this one, these can be very easily found on the internet if you look out for this. So if you just see in this example as well, we have supplied a domain over here that will simply just, if we replace all the data from the SAML response, encode this payload over here and put in place of SAML response. So it can be easily used to, trigger XXE as well, because this will also be implemented as XML. And if there's not proper preventions for this, so you can also try to, perform this kind of attack. So third, this one is, like something which was like discovered in like recent times, and it's like a authentication bypass vulnerability that you have. So how this works is, in SAML we have discussed that there's a SAML response which is simply working on XML language. So what we try to do is we simply try to take advantage of the fact that the SAML parsing libraries also cut out or look out for all of the comments that are there. So any sort of unwanted text such as comments is not included in the token values. So what we do is, in the name ID we try to like insert a comment over here, so that once this comment is removed, like it's passed through the library and then it's removed, so it can simply result back to the admin of that particular website. So what we mean to say is that, if we just bring it back to this scenario. So yeah, so as you can see here, we tried to use admin at website.com. Now at times it could be possible that they have blacklisted this certain keywords, that admin something like this cannot be requested by like in SAML response. So it could throw an error. So here we try to bypass that particular thing, that we won't directly write admin inside the name ID field. But what we'll try to do is we'll try to insert a comment in between, which will be removed by the the processing of your, like it could be either by identity provider. So while processing, it will remove out this comment, and once the comment gets removed, if you look at the resultant, it will be ADM and IN. So it will result to admin at like SP, which is service provider at website.com. So if you see, the XML tree after parsing will look like your text will be ADM. This will be your comment. So what we have placed inside this is the general notation that you have for HTML and XML for commenting out data. And then you have text as this, which is written after the comment. So it will simply strip off the comment and just append both of them, which will result to admin at spwebsite.com. Simply you can bypass filters using this particular thing. So
Like, yeah. Abhinav
Yeah.
already told, we can insert comments to bypass this particular thing. And
Hmm.
if you're wondering if this is the only way, or if it is the only place where a comment can be inserted, it is not. It can, like, the comment can be inserted, like various XAML parsing libraries parse that particular text comment and text field in different ways.
Yeah.
There can be some parsing libraries which take the first field. For suppose here we do have this particular thing of text, which is ADM. Some particular parsing libraries can consider only the first encountered text as their name ID. There can be some scenarios in this particular case which we encountered where the comment was being stripped off and the other two text entities, or like the number of text entities present in that particular same entity, were being like concatenated to form the final text field. Or also there can be some logic where the only the last entity or the last text field has been stripped and that particular thing is only being used. So the insertion of command can be like at various places, and this completely depends on the parsing logic of that particular SAML library. So you can play around with inserting the comment at various places and see if one of those places works out. Yeah. So now moving on to the preventions of SAML, we do have like the four standard things that most of these SAML service providers tell us. One of them is SAML Assertion should be encrypted if the feature is supported by service provider. So what this means is, since we have seen here that there is something known as Saml Response, which we are like directly decoding. Since it's a decoding mechanism, it can be easily decoded through online decoders or even like with simple decoders. So what these companies tell that if the service provider, that is for suppose here Dell or some other service provider that we are using, supports encryption feature. So they use encryption to encrypt that SAML response so that the particular person who intercepts the request, even if he intercepts it, need that particular encryption key to like decrypt that particular SAML response. Only then will he be able to tamper the request. So other thing that is the authentication request can be signed to help ensure the request is being sent by trusted service provider. So what we do here is we sign that particular thing. So what happens here is there's a signature that is passed along with that authentication request to check whether the request is coming from our service provider or has it been intercepted and it is coming from some other service provider. And three, here we are asked to use SHA-2 algorithm when designing SAML workflows. We do have the previous versions of SHA-1, which are not like that secure as SHA-2. So these particular SAML providers ask us to use SHA-2. And there, for the communication purposes, most of the times they ask us to use only TLS version 1.2, as this is one of those versions providing modern authentication encryption. So these are the four standard things that have been told to us. And also the other mechanisms like can be, or the things that we have seen is, if you are guys are some of you might also be developers. So since we have seen that the most of the tampering part happens in this particular thing of what you call the name ID part and the signature part. What can be done is make sure that you are validating the SAML, like the signature associated in the assertion, and also not just verify if there's a signature present, if it is the signature associated with that particular name ID, so that even if the name ID is tampered and if it does not if the signature does not correspond to that particular name ID, you can like deny access to that particular person. These are few of the prevention methods that
Yeah.
can
And
be
like
like.
input validation could also be one of them, but like as we saw in this particular example, that if you just simply blacklist admin keyword for instance, so it could be bypassed by using several like regex techniques. So it is a prevention mechanism, input validation, but definitely like keep it as the last one. So there are a lot of good ones as Naveen discussed. So if these are used by your like identity providers, so definitely it could help. So like an identity providers such as OneLogin or Okta, all of them are like working on making it secure each and every day. So it could be a good thing. And secondly, infrastructures such as Yahoo, they tend to use their own SAML services that they have created. So that simply means that they don't like usually go for Okta or OneLogin kind of like identity providers. So they'll try to just build their own, and that could also be done by anyone of us as well, but that is a very hectic task. considering that there could be a lot of say thousands of subdomains to like keep note of. And apart from that, a lot of times what happens is when you also include network domains, restricted IP addresses, or like CIDR blocks. So you also have to like look into Active Directory implementations, how you wanna like set up the privileges for each and everything. So like SAML is a very typical thing when you just want to do it, and you want to set up on your own. So that is why usually companies prefer, something such as Okta or like one login. So these are the ones which are used. But definitely there could be some integration like faults that we discussed. So usually when the information is flowing, like from one place to another. So in those times, if the everything is not validated properly, so we can try to tamper the data as we discussed in the attack scenarios, and that could lead to some sort of vulnerability. So whenever you're testing for large infrastructures, always look out for login areas, how the login is working. And if it is a SSO or a SAML implementation, so definitely just always look out for the SAML response and what all you can do with it. You'll also find a lot of guides on the internet that are actually going to help you, which you can refer. OWASP has a lot of guides for this. So for developers as well as for pen testing cheat sheets as well. So yeah, I think we had this much in our talk. So
So, you
thank you
guys,
guys. So
thank you for
thank
attending,
you.
and
Thanks a
if you
lot.
guys increase.
So, thank you, Abhinav. Thank you, Naveen. It was a nice session. It was some good information about SAML and SSO pentesting. So, again, thank you from Red Team Hacker Academy. So, thanks for giving your time, coming here, and giving insight on the topics, guys. Thank you so much.
It's
Thank you.
our
Thank you for
pleasure.
having
Thank
us.
you.
Thanks.
Guys, we have a session starting on IoT pen testing. So, you can switch over to that particular corresponding session. So.